All right, we're going to run through a couple of example questions on the normal distribution from past exams. So these are typical questions that will come up in exams. Let's start with the first one. A machine produces nails with lengths that follow a normal distribution with a mean of 36 millimeters and a standard deviation of 0.5 millimeters. So in the notation we've been using, we can write that as x is normally distributed with a mean of 36 and a standard deviation of 0.5. Question A, state the probability that a randomly chosen nail has a length less than 35.3 millimeters. So again, using our notation, we want the probability that x, some randomly chosen nail, has a length of less than 35.3. And to answer that, you'll notice it's only 1 mark, and that's because it's really only one step, and that is going into our calculator, calc up the top. We want distribution, normal CD. Our lower limit is 0, and our upper limit is 35.3 because we want to know all the nails shorter than 35.3 millimeters. Our standard deviation was 0.5 and our mean was 36. And it gives me a probability of 0.081. I'll round it to 2 significant figures, 0.081. Next question, exactly 35.3 millimeters. Well, this is the word that's important there, the word exactly 35.3 millimeters. The chance of a nail being exactly that length is 0, because exactly 35.3 means 35.30000 going on forever. So 35.3001 is not exactly 35.3. So the chance that it's going to be exact is 0. And we can confirm that by going into our calculator. And what if we made the lower limit 35.3 and the upper limit 35.3? So that means that the nail would be exactly 35.3 millimeters. And the probability of that happening is 0. Third part, between 35.3 millimeters and 36.3 millimeters. So using our notation, we now want the probability that x is between 35.3 and 36.3. So using our calculator, we're going to make the lower limit 35.3, the upper limit 36.3, and I get a probability of 0.64. Okay, question B. The longest 5% of nails are discarded. What length do the discarded nails exceed? Okay, so this is a question where instead of us coming up with a probability or a percentage, they are giving us the probability or percentage and asking us to come up with a length. So this is an inverse distribution question. So I'm just going to draw my distribution here. And I'm looking for the length that the discarded nails exceed, meaning greater than. So if the longest 5% are thrown out, then what is the length where above that the nails are thrown out? So on my distribution here, I'm looking for some length over here where the probability of nail being in that red area, meaning longer than that length, is 5%, or 0.05. So for this, like I said, we need inverse distribution. So I'm going to go back out to here, and instead of distribution, I want inverse distribution, inverse normal CD. tail setting. Well, if you can see on my diagram, we're looking for the area off to the right there. So I want my tail setting to be right, my probability to be 0.05, my standard deviation is still 0.5, and my mean is 36. And I get a length of 36.82 millimeters. That's what that length there would be. Okay. Again, that one's only worth 1 mark because it's really just one step, and that's putting it into your calculator. This next one is worth 3 marks because there's a few more steps involved. Let's read it. 2,500 nails are produced, 1,800 of which have lengths within X millimeters of the mean. Determine the value of X. Okay. This is an extra step, first of all, because instead of giving us a percentage or a probability, it's giving us a number. So it's still asking us for the length, which means it's an inverse distribution question, but we need to work out the percentage or the probability based off the numbers that it gives us. So our first step is to work out the probability. All right, so the probability of falling within these 1,800 nails that have lengths within X millimeters of the mean is going to be 1,800 out of the 2,500 nails that we have in total. I'm just going to use my scientific calculator for that. 1,800 divided by 2,500 gives me a probability of 0.72. Okay. Now I'm going to draw my distribution. So I'm looking for, if this is my mean of 36, I'm looking for the values on either side of the mean that give me a probability of 0.72. So in other words, I'm looking for a value there and there, where this red shaded area between them, the probability of a nail falling in that area is 0.72. So now it becomes a standard inverse distribution question where we're looking for, if I bring up my calculator again, we're looking for the center, so tail setting center. Probability now is 0.72. The standard deviation and the mean are still the same, and it gives me these two numbers. So this is step 2 now, finding the values on either side of the mean. So it's telling me that X has to be between 35.46 and 36.54. X is between those two values. So that means that this value here is 35.46 and this value here is 36.54. Now my third step is to calculate X, because within X millimeters of the mean means from the mean to my upper value, that is X, and from the mean to my lower value, that is X. So to work that out, I need to do my mean, 36, minus my lower value, 35.46. And if I just chuck that into my scientific calculator, 36 minus 35.46, it gives me an answer of 0.54. And I could have done it the other way around as well by using my upper limit. I could have done 36.54 minus the mean to work out this distance here, and that would have given me the same answer, 0.54. So my answer is X equals 0.54 millimeters. Okay.